Hello guys, so this is lecture number 6 of the trigonometry today, and today I have 10 important questions for the board exams, and these are the questions. If you look at the previous year's board papers, then you will find it that one of these 10 questions is always in the board exams. So I'm just going to solve these 10 questions for you, and if I'm sure that if you solve these 10 questions and you are able to solve the sum, then same question, not even similar question is coming to you, just as it is whatever I am teaching you, as it is the question will come in the your board exam. If you see the previous year trend, then as it is questions are coming in the board exam. So these are very important questions from the trigonometry. I'll just tell you how to solve these questions. So the first question, which is the first question is cosec theta minus cot theta whole square 1 minus cos theta 1 plus cos theta. So before that, I just tell you in short that in these all 10 questions we are going to use only 3 formulas. The first formula is sine square theta plus cos square theta is equals to 1. Another identity we are having, that is 1 plus tan square theta is equals to sec square theta. Next one is 1 plus cot square theta is equals to cosec square theta, and one formula we are using in this one, that is tan theta is equals to sin theta upon cos theta. You are already aware that sec theta is 1 upon cos theta. Cot theta is, this is cot, is equals to 1 upon tan theta, and cosec theta is 1 upon sin theta. Clear? So we will just use these formulas and some identities. These are identity and this is a formula we'll be using in this one. And if you are very new to this topic, you don't know sin theta and cos theta, then you have to watch my first 5 lectures in order to get what are the sin theta and cos theta and tan theta. So I recommend to continue with this lecture. Before this one, you have to watch from 1 to 6 if you don't know the sin theta and tan. If you are very much comfortable on this one, then you don't have to worry about this one. Okay, let's solve one by one. So as you know, this cosec theta is 1 upon sin theta, and please keep copy and pen with you and keep solving with me. If you do just watching by yourself, then you will not get anything, you will not able to solve this one. And this cot theta, I haven't told you this, let me write it down. Cot theta is cos theta upon sin theta. Actually this is 1 upon cot theta is 1 upon tan theta, 1 upon tan theta, and tan theta is sin theta upon cos theta, so it got reverse, cos theta upon sin theta. So here sin theta will be the LCM, and you get as 1 minus cos theta, correct, and square here. So next you get it as 1 minus cos theta square upon sin theta square whole square, and we write this sin theta whole square as sin square theta. If you are new to this one, you might know. If you are used to solving this question, then you are keep very aware that we write like this. And from this sin square theta plus cos square theta, we will use sin square theta will be equals to 1 minus cos square theta, right? If you write it here, then sin square theta will be is equals to 1 minus cos square theta. That will be equals to 1 minus cos square theta. So the same value I will put it here. So it will come as 1 minus cos theta upon, sorry, this will be square formula square, 1 minus cos square theta. And this 1 minus cos square theta can be written in the form of a square minus b square, which is having term as a minus b, a plus b. Correct? So I will just use this formula here. A is 1 and b is cos theta. So the question becomes as 1 minus cos theta square 1 minus cos theta upon 1 plus cos theta. Clear? So this will become as, and from here 1 minus cos theta 1 minus theta get cancels. This comes as 1 minus cos theta upon 1 plus cos theta, and that's what we have to prove from the right hand side. These are all questions which we have to prove LHS equals to RHS. So these are all questions are like prove this, that's it. And I just tell you these questions are from NCERT. Question number 5, exercise 8.4, question 5, all parts. Next we are having that we have to prove this one, this term is equals to sec a, correct? So we will do, how we'll do, we just solve the left hand side here. So in the bottom we just take LCM here, that will be LCM take as cos a 1 plus sin. So if you know the rule of LCM, how we do, 1 plus sin a, we divide on this one, this becomes as cos square a plus 1 plus sin a square. If you know how to take LCM. If you don't know, then what, please watch the previous lectures. Cos square a. Here we will use a plus b whole square formula, that is a square plus b square plus 2ab. A is here 1, b is sin a, so it will become as 1 plus sin square a plus 2 sin a upon cos a 1 plus sin a. If you rearrange this cos square a, it becomes like this. We can write cos square a together sin square a plus this one here plus 2 sin a, like this, and here it is cos a 1 plus sin a. From the first identity, what I have just told you, that cos square a plus sin square is 1. So this value becomes as 1. Let me write it here at the top. So the first term becomes as 1. This becomes as 1 we already have, that is plus 2 sin a divided by cos a, and bracket we are having 1 plus sin a, that is 2 plus 2 sin a upon cos a 1 plus sin a, that is 2 1 plus sin a upon cos a 1 plus sin a. So this 1 plus sin a 1 plus sin a gets cancelled, and here you get the result as 2 upon cos a, and 1 upon cos a is sec a, so this becomes as 2 sec a. Clear? Any doubt to anyone? Anyone is having doubt? No? Let me have a look. Okay, no questions. So I take that everyone have no questions right now. So let's move to the next question. So the third question is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equals to 1 plus sec theta cos sec theta. So we have to prove from the left hand side to the right hand side. We have to prove that one. So let's solve the left hand side. That is left hand side. So what we do, just change this cot theta here. This becomes as tan theta upon 1 minus 1 upon tan theta, and just keep the second term as it is, cot theta upon 1 minus tan theta. While in the book it has been written as this, I think that changed sine theta cos theta. If not even then we solve like that and we get the correct answer. We will get this right hand side, so don't worry, just solve it with me. I hope you are having this pen and paper with you. So at the denominator, let's take LCM as tan theta, and you get it as tan theta minus 1, and then at the numerator you are having tan theta plus second term remains as it is, cot theta upon 1 minus tan theta. So if you solve this one, this tan theta from the denominator goes to up in the numerator and it becomes as tan square theta upon tan theta minus 1 plus cot theta upon 1 minus tan theta. Okay. Now what we do, we just take negative sign common, because in the denominator we are having tan theta minus 1 and 1 minus tan theta. If you take negative sign common here, so the terms remains common, tan theta minus 1, or either we take negative sign common here in the first term or in the second term, anywhere we can take. So for the simplicity I am taking on the first one here, so it becomes as minus tan square theta upon 1 minus tan theta 1 minus tan theta plus cot theta upon 1 minus tan theta. So the LCM remains 1 minus tan theta, and this becomes as tan square theta plus cot theta. So we might have changed the cot theta as well in tan theta, but we have not changed earlier, so now we will change it right now. So this minus tan square theta plus 1 upon tan theta here upon 1 minus tan theta. So after taking LCM, the terms becomes this minus tan cube theta plus 1 upon tan theta at the numerator. In the denominator it is 1 minus tan theta, what it was, correct? So this minus tan cube theta we can write in the numerator, we can write like this, 1 minus tan cube theta, and this term tan theta comes in multiplication with this term, so this becomes as, this terms becomes as tan theta 1 minus tan theta, like this. Clear? Now what we are going to do, we will use the formula 1 minus tan cube theta, right? We are having here 1 minus tan cube theta, so we know the formula of a cube minus b cube. What is this one? This is a minus b, a square plus b square plus ab. So here we will take a as 1, b as tan theta here. Okay, so if you solve like this, so this terms becomes as 1 minus tan theta, because a is 1, b is tan theta, and now we are having a square, so a square is 1 square, that is 1, plus b is tan theta, so that is tan square theta, plus ab, 1 into tan theta, so that is tan theta. and the denominator remains as it is, tan theta upon 1 minus tan theta. So as you see, that's 1 minus tan theta and 1 minus tan theta get cancelled. It remains 1 plus tan square theta plus tan theta. And from the identity, we know that 1 plus tan square theta is sec square theta. So it becomes as sec square theta plus tan theta upon tan theta. Correct? So now we will just separate the terms. Because right now tan theta is LCM here, how we write like this? If we separate the terms, then it becomes as sec square theta upon tan theta plus tan theta upon tan theta, right? We write like this, that tan theta in the bottom of this one, tan theta in the bottom of this one. Now I don't have the space here, so because here below that one my video will be coming on the screen. So what can work? Okay, let me write it here. So this will be the first term, this one, tan theta upon tan theta, that becomes as 1, right? So we will write it as the first one, we will write it like this 1. The second term is sec square theta upon tan theta. So let's change this one to cos and sine. So this becomes as 1 upon cos square theta into tan theta is, right, here it is tan theta. So tan theta can be changed as sine theta upon cos theta. Let me change the color so it will not mix up this. So this terms now, where can I write? I don't have space. Okay, let me first, it is clear that this 1 cos theta and 1 of this power will be cancelled. The term remaining is 1 plus 1 upon cos theta sine theta. Correct? So now you can see this 1 plus, and this 1 upon cos theta will be sec theta, and this 1 upon sine theta will be cosec theta. So that's what we have to get. This 1 upon cos theta is, this term becomes as sec theta, and 1 upon sine theta will be, this can be written as cosec theta. So that's what we have to prove. So this is our answer, or in fact we that got with the, that is equals to right hand side. So we started from LHS, reaches to right hand side. Let's move to the next question. So the fourth question is 1 plus sec a upon sec a is equals to sine square a minus 1 minus cos a. So we have to prove this one. So let's start from the left hand side. Let's take left hand side here. Let's change this all 1 plus sec a into cos a. So 1 plus 1 upon cos a upon 1 upon cos a, okay, like this. Let's take cos a LCM in the numerator. So this becomes as cos a plus 1 divided by 1 upon cos a. Cos a get cancelled. This becomes as 1 plus cos a. Clear? Here we are having here simplify LHS and RHS separately. So I will just solve. Now I will solve the right hand side and we'll check that we are getting the same term or not. So the second term RHS side is sine square a. Sine square a, as we know that we are having identity sine square a plus cos square a is equals to 1, right? So from this, if we calculate the sine square a, then sine square we get it as 1 minus cos square a. And if you solve all these 10 questions, your 5 quick marks are secured in the board exam right now. correct? So just bear with me and just solve these 10 questions with me. If you just solve these 10 questions and you just mug up, if you just don't understand even, just memorize. Some of the guys are like that, they just have problems in the solving the question, so you just don't solve it, and if you just memorize it and just pour as it is in the board exam, even then your 5 marks are secured, because these are the 10 questions which are about to come, or just definitely they will be coming on the one of the question will be coming in your board exam, and if you just pour as it is in the board exam, your 5 marks are secure. So just bear with me, and if you solve it with me, if you understand it, that is very good. And if you don't understand, you can pour as it is, no problem with that one. But your 5 marks are secured if you are with me for the coming 20-30 minutes. So now this becomes as 1 minus cos square a upon 1 minus cos a. So this 1 minus cos a, here I am using the formula for the a square minus b square, that is a plus b, a minus b. So 1 minus cos a, 1 plus cos a. Here a is 1 and b is cos a, and the denominator we are having 1 minus cos a, 1 minus cos a, 1 minus cos a gets cancelled, and the result is 1 plus cos a. That's what we have got in the left hand side here. So that's how LHS is equals to RHS. And in the bottom, if you are very happy, then you can write in the red color. What you are going to write in the red color? Oh, very, very, very popular. Hence proved. Right? And as we know, in the board exam, when we write this hence proved, then it's like that we have got 100% marks in the mathematics. So that's going to happen. So let's move to the next question now. The next question is question number 5. This is the toughest question. Then the such type of question in the example as well. I think I don't remember the example number. If you were watching my previous class, lecture number 5, then I was with you solving the similar type of questions. But this is also important, so I will just shout out with you. Let's solve it. Here actually, if you observe minutely, then you are seeing that here on the right hand side we are having cosec and cot A. Here you don't have cosec and cot A, so it is very important then you make the terms in cosec and cot A. And the one more thing that they are saying that you have to use this identity cosec square A 1 plus cot square A. So definitely you have to put these terms in the cosec A. To put these terms in the cosec A and cot A, you have to divide numerator and denominator by what term? Yeah, by what term? Yeah, correct, sin A. So let's divide numerator and denominator by sin A. So cos A minus sin A plus 1. I will write small letters, otherwise I always run out of space. Cos A plus sin A minus 1 upon sin A. So you see that I'm dividing numerator and denominator both sin A. So if you go to reverse, then sin A gets cancelled, and remaining term is cos A minus sin A plus 1 as it was earlier, right? But we are making it now in terms of cosec and cot A. So now we will bifurcate. We will write cos A upon sin A upon sin A, and 1 upon sin A. So cos A upon sin A, this term, let me like this, cos A upon sin A minus sin A upon sin A plus 1 upon sin A divided by cos A upon sin A plus sin A upon sin A minus 1 upon sin A. So this first term becomes cos A upon sin A. This becomes as cot A minus 1 sin A. Sin A is cancelled, and this is cosec A. And at the denominator we are having cot A. This terms becomes as 1 minus cosec A. Correct? So that's what we get it, but it's still no glimpse of our right hand side, which is cosec A plus cot A. Correct? You are with me? We don't have any idea that how to reach this cosec A plus cot A exactly. We don't have this term, so what we will do, we will just multiply and divide by this terms cosec A plus cot A. Okay, let's multiply and divide with this term cot A. Let me take another color here. Just lighter, getting this one. Cot A and minus 1 minus cosec A divided by cot A plus 1 minus cosec A into, with what we are going to multiply and divide? Yes, we are going to multiply and divide with the term what we are having in the right hand side, and the term is this one, cosec A plus cot A upon cosec A plus cot A. So if you just don't do anything, then it is simply gets cancelled, numerator and denominator, and the term remains as it is. But we are going to multiply and divide this one with this term. So now we will go to the going to solve it. So here the clue is this one, that we have to get in the right hand side as this term cosec A plus cot A. So we will not mess up with this cosec A plus cot in the numerator, because we have to get it in the numerator, so we will not mess up with the numerator term. We will just multiply in the denominator terms. So this will be cot A minus 1 minus cosec A. We will keep the terms as it is, this one in the numerator cosec A plus cot A divided by this, let's multiply this one cot A. Okay, if I change the colors, then I think it will take very much time, so I don't change the color repeatedly. Cosec A cot A cosec A plus this will be cosec A minus cosec square. So this was the terms multiplied by the cosec A. Now let me change it for the lighter color, and which is multiplied by the cot A. So cot A will be this one, cot square plus cot A and minus cosec A cot A. So here you are having this cosec A and cot A here, and cosec A cot A here, that is positive and that is negative, so this gets cancelled here now. Correct? So here coming will be my video here somewhere. Where is my video? Oh yes, it is. So I will not write anything on this space. Okay, let's make it a little bit darker. So this will be, numerator remains as it is, we are not going to mess up with the numerator. Cot A minus 1 minus cosec A and cosec A plus cot A, and this denominator terms becomes cosec A minus cosec square A. Here we are having the correct formula they has given by the question writer, and they have told us that we have to use this formula, cosec square A is equals to 1 plus cot square A. So I'm going to put these value in this question. 1 plus cot square A, and correct, this is done. Now plus we are having that lighter color we are having cot square A plus cot A. So I'm doing little shortcut here, or let me not, if I have to keep it is, and oh, yes, I'm just writing this one here, center it and put it on full screen. Now I have one more page. So now we are having cot A and minus 1 minus cosec A, minus 1 minus cosec A here, and the multiply, it was cosec A minus cot A, correct? Cosec A plus cot A. So in the multiplication we are having cosec A plus cot A, and in the denominator we are having as cosec A. And if you just observe this one, this will be negative cot square and this will be positive cot square wave, that gets cancelled, and the terms remaining is this term. I'm just writing here the term remaining in the denominator only. I'm writing here cosec A, and this will be minus 1 here, right? This minus goes inside the bracket, so this is minus 1, and this term remains plus cot A. So that's what I'm going to write in the next page, that is cosec A cosec A minus 1 plus cot A, minus 1 plus cot A. Good. So let me rearrange the denominator, and the numerator remains as it is, cot A minus 1. Some of the guys are just very intelligent and they just observing this one, that numerator first term and the denominator is similar, they are having the same value. Exactly, you are right. I'm just rearranging this one. So the cot A minus 1 plus cosec A. I think we have some mistakes here. Somewhere. Yes, here it is. This is plus sign here, 1 minus sin A. This is plus cosec A here. If you observe this one, this is plus cosec A. So this will be plus sign here. So this will be here plus cosec A, and here it will be where this is plus cosec A. Here also it is plus cosec A, and here it is plus cosec A, and here it is plus cosec A. Correct. So now these terms get cancelled. Clear? So this becomes as cosec A plus cot A. So that's what we have to prove in the right hand side. That's the answer, cosec A plus cot A here. Correct? That's great. So guys, you're not telling any of the mistakes I'm doing. You're just simply sitting idle. I think you're not having this copy and pen with you. So I'm just saying once again, just solve it with me. If I'm doing any mistakes, then keep telling. I see that nobody has just tell me that what I have just done. Yeah. So keep telling. If otherwise, we will just waste our time here. That's it. Okay, let's move to the next question. The next question is 1 plus sin A, 1 minus sin A, root of that one is equals to sec A plus tan A. So let's sort it out. The left hand side, which is written as root of 1 plus sine A upon 1 minus sine. What we are going to do, we are just going to divide and multiply by this term 1 plus sine A upon 1 plus sine A. Now you guys will be thinking why we are dividing and multiply this by this 1 plus sine A and 1 plus sine A. How you come to know? Because your teacher, you know that you have to do this one. How can I do? Because I am simple student, very 10th class student, and how can just multiply into a term? Yeah, definitely I know that you are very new to this one and you just don't know which term to multiply into it. That's why I say that you have to make a lot of practice, that how to see the right hand side. Because if you watch this term right hand side, we are having plus sign here, so that's why we have multiplied this 1 plus sine A upon 1 minus plus sine A, numerator and denominator. So this needs practice. Once you are getting practiced, then you know which term to multiply or which term to divide. Another way is to solve this one, that we will solve this left hand side and solve the right hand side, then also you can get this one. I think this is root down, you cannot get that one, so you have to go this way only, there's no other way. Let's solve it. So you need practice to get such type of questions, otherwise you will not able to solve it. 1 plus sine A whole square, and this becomes as A plus B and A minus B, A plus B. So finally it becomes as A square minus B square, right? So in the numerator we will use formula as A plus B whole square, and the formula we are having as it is A square plus B square plus 2AB. A is 1 here, so I will write it as 1 square plus sine square A plus 2 sine A, and the denominator, oh, I just write it as A square minus B square. That's great. So this becomes as 1 minus sine square A, correct? So let me write it here now. So in the numerator it becomes as 1 plus sine square A plus 2 sine A upon 1 minus sine square A. 1 minus sine square A becomes as cos square A. Oh, I have just done mistake here. We don't have to open this one. If you open, then we don't get the term. So let's keep the numerator as it is, 1 plus sine A square upon cos square A. And if you take the square root in the terms, this becomes as 1 plus sine A. In fact, that was not a mistake. I had to explode. That's it. So 1 plus sine A, that terms becomes as 1 plus sine A upon cos A. If you just put separate terms, let me write it here because you might have avoided my video here. So let me write it here. Okay, let me change the color now. So this terms becomes as 1 upon cos A plus sine A upon cos A. So this becomes as sec A plus tan A, and that's what we have to prove in the right hand side. Clear? Great. Let's move to the next question. Next question is, we have to prove sin theta minus 2 sin cube theta is equals to tan theta upon 2 cos square cube theta minus cos theta. That is very easy question. Just take the terms sin theta is common here. 1 minus 2 sin square theta, and the denominator we take cos theta as common. 2 cos square theta minus 1. So we know that this sin square theta plus cos square theta is equals to 1. So we will use that formula as 1 minus 2, and sin square theta is 1 minus cos square theta. Exactly, that's what we are having. And then the denominator we are having as cos theta, 2 cos square theta minus 1. Clear? That's great. We are going to be genius now. Sin theta, and this 1 minus this term goes inside, minus 2 plus 2 cos square theta, right? And in the denominator terms remains as it is, cos theta upon cos theta multiplied by 2 cos square theta minus 1. correct? Numerator terms 1 minus 2 becomes as minus 1. So let's write sin theta first, and then inside the bracket 1 minus 2 becomes as minus 1. So let me write it as minus 1 plus 2 cos square theta. In the denominator we are having cos theta 1 minus 2 cos square 2 cos square theta minus 1. 2 cos square theta minus 1. So in the numerator and denominator we are having minus 1 plus 2 cos square theta, 2 cos square theta minus 1. So some of the guys say that these are the same thing. Oh, some of the guys students don't say that this one. Okay, no problem. Let me rearrange it. Now you will say it. This becomes as 2 cos square theta minus 1, and this is also now you say right, 2 cos square theta minus 1. Good. So now they get cancelled and the terms remains as tan theta. No, because this is sin theta upon tan cos theta, and that is what tan theta. That's what we have to prove in the right hand side. Clear? Okay, let's move to the next question. Next question is sin a plus cos sec k whole square plus cos a plus sec k whole square is equal to 7 plus tan square a plus cot square. Most of the students don't try this question. This is very easy questions, but they always say, oh my god, how 7? When they see this term 7, they are very strange, how 7 can come. No, I cannot solve it. But actually this is a very easy question. Just open the square of these formulas. So this becomes as a plus b whole square sin square a plus cosec square a plus 2 sin a cosec a. Second term remains as cos square a. Let me have it here. Cos square a plus sec square a plus 2 cos a sec a. Clear? We are just solving the left hand side, so let's write left hand side. We just not mess up the right hand side. Now let's solve it. Oh, I just missed a here. Now this sin square a here and cos square a here. Let's write it together here now. Sin square a plus cos square a. That's very good. Another term we are having cosec square a. Cosec square a formula we are having as 1 plus cot square a. If you guys don't remember the identities, this is 1 plus cot square a. So sin a cos a is gone, and the next term is our sec square a. Sec square a can be written as 1 plus tan square a. Correct? The term remaining is 2 sin a cosec a. So let's write it as 2 sin a, and cosec a remains as 1 upon sin a. This is also remaining, so we can write it like this: 2 cos a into 1 upon cos a, because sec a can be written as 1 upon cos a. Okay, let's close the bracket now. So this sin square a plus cos square a becomes as 1, and this 1 becomes plus 1 cot square a. Let me write it together here as of now. Good. This one, okay, nice, plus tan square a. Let it write like this as of now. This sin a gets cancelled, so this becomes as 2. This cos a gets cancelled, so this becomes as 2. So how many numbers we are having right now? 2, 2, 4, 5, 6, 7. We are having 7. Finally we get this term, the most difficult term. Finally we got it, and the term remaining is cot square a and tan square a. Cot square a and tan square a. 7 plus cot square a plus tan square a. Oh yes, you got it. So that is our right hand side, and the most magical word. What is this magical word? Oh yes, they are. Let me write it because I feel good by writing like this. Okay, my pen is not working. Oh yes, now this. And the most magical words are hence proved. When I was studying in my 10th class, then some of the times I don't get this answer, then still I write this hence proved. And some of the times teacher gets confused and they just give, okay, like looks like this student have done this, so finally they give the answer. But once I caught it, then my teacher was intelligent. Once he caught it, oh, well, this is not, you got it, and he just crossed my marks and given me two slap as well while writing this hence proof. So sometimes we get benefit and sometimes we don't get. Okay, this is our next question. That is ninth question. Cosec A minus sin A, sec A minus cos A. Okay, let's solve it. Okay. Cosec A is 1 upon sin A. We are just solving the left hand side. And this is minus sin A here. And the second term is 1 upon cos A minus cos A. Correct? So let's take LCM here. This is our sin A. This is 1 minus sin square A. This is the first term here. And the second term is, we take LCM here as cos A. This becomes as 1 minus cos square A. 1 minus sin square A can be written as what? Now you might have just got it. This is cos A and this is sin A. Oh, that numerator is sin cos square A. And this 1 minus cos square A can be written as what? Yes, exactly. Now you just, in the words, whenever say like there's no Bharat Mata ki, then next word is Jai. So it's like that it's happening now. Sin square A 1 cos A. So cos A, and now you will cancel these terms. Let me write it here. This cos A gets cancelled. 1 from cos A here, so this 1 of the power goes here, sin A is like this, goes here, and the terms comes as, let me write it here, because we have to solve right hand side as well, right? So left hand side comes as sin A upon cos A. Let's solve this right hand side now. So this is our LHS left hand side. And now we solve the left right hand side, and if we solve left hand side and right hand side and we get the same result sides, sin A cos A, then they are correct. If we don't get the same result, then we are doing something wrong. So let's solve it. So this 1 upon tan A is our cos A upon sin A. No, this cot A is cos A upon plus sin A. This cot A, sorry, cos A upon sin A plus tan A is sin A upon cos A. Luckily they are plus sign, so I don't have to change it actually. I'm lucky here. So let's take LCM in the denominator. So this is our sin A cos A. So denominator becomes as cos square A plus, here this comes here terms, sin square A. And most of the students are very intelligent and they know it, that sin square A plus cos square A, that is 1. So the result comes as 1 upon sin A cos A. So because this term is sin square A plus cos square A, that is 1. So now this term goes at the above numerator and the terms comes as sin A cos A. Great. So that's what we in the left hand side right here, and now we get it in the right hand side. So that is the correct one. So finally we have done 9 questions and this is the 10th question we are going to solve. And after these 10 questions, your 5 marks are secure in the board exam. Not even this local school exam, this from the board exam, your 5 marks are secured. Let's solve it. Here what we have to do, we have to prove these 2 terms as tan square A. So let's sort this first one, that says as 1 plus tan square A upon 1 plus cot square A. So the first term is little easy, second is little complicated, although both are easy. So write it like this, 1 plus tan square A upon 1 plus 1 upon tan square A. Okay, it is here now. So this 1 plus tan square A, let's take LCM here, that is tan square A. The terms becomes as tan square A plus 1. right? If you rearrange it, some of the guys are very confused at how to solve these type of things. This tan square a comes here or in the bottom, so let me write it for you because these guys are always confused. If we are having like this p by q by x by y, so what happens here, this p comes here and q comes here, so it becomes like this py by qx. Clear? Some of the times what is happening is written like this, numerator is p and in the denominator we are having x by y. So you just have to keep in the mind what is happening. When this is the case, then we assume that it is like this p and the denominator is 1 and then we have big line and we are having x by y. So in that case, this p is multiplied this y and this like this, and then we write like this py by x. So this is the case when we are having two terms in the denominator and just single term in the numerator. So it becomes like this, 1 plus tan square a. Before that we have taken as 1, suppose that one, and this is tan square a plus 1 divided by tan square a. Correct? So what is happening? This tan square is going at the numerator at the top and this is coming here. So this comes as 1 plus tan square a into tan square a divided by 1 plus tan square a, and here this tan square a get cancelled and the final result remaining is tan square a. That's what we have to get it here. Nice, very nice. Let's take the second term, and the second term, let me write it with the different color. I like green color very much. Okay, let's take blue color this time, not always green, huh? So the second term is 1 minus tan square a. 1 minus tan a, let it like this, put it square here, and in the denominator we are having 1 minus 1 upon tan a, right? Good. Now we are having 1 minus tan a at the numerator, and here we take LCM as tan a and take this tan a minus 1. So the terms becomes like this as it was happening here, right? Similarly, we will be having this like this, 1 minus tan a, oh don't forget the square here, 1 minus tan a upon tan a minus 1, and the multiplication here is tan a. This tan goes at the numerator and it becomes like this square. Oh, I think my video will be coming now. My video is a big problem now, always comes. Okay, let me take use this space. Good. So what is happening now? This is 1 minus tan a, this is tan a minus 1. So what we will do, we will take minus terms as common here, and this term also becomes as tan a minus 1. Correct? We have a big bracket with the square here, and the tan is also written here inside the square, and this is tan a minus 1. So now this tan a minus 1 gets cancelled, and inside this bracket remaining term is minus tan a square. And you guys are just genius, you know that what is the minus tan a square. Exactly, minus square is always plus, and tan a square we write like this, tan square a. So finally we get the result as tan square a from the right hand side as well. We solve this term, first one, and the second terms. We solve both the terms and finally the result as tan square a. And now these all 10 questions are covered, and you are now, your 5 marks are secured now. But still, practice makes a man perfect. if you make a practice, even then only you will get good marks, because 5 marks are not sufficient or not enough to get pass. Not, pass is not happening nowadays, but still 5 marks are not too good. You should practice a lot. You should not leave the practice, and it is very important that you practice from the different books, explore different types of questions, and you can take R.D. Sharma, R.S. Agrawal, any book for the different question, variety of the questions. You solve it, you make yourself comfortable with this type of questions. And once again, if you are not subscribed to our channel, then please subscribe. So when I upload the new video, you get notification automatically that I have uploaded something, and you can watch and get benefit from this. And please share with other guys, so they will also get a benefit of that one. Yes, if you have any questions on this topic, just please write the doubts on the comment box. I will reach you and sort this out immediately. Or you can write an email to our email ID, that is matrixlearning@gmail.com. You can write to email with your doubts or new questions. I will solve the question for you and mail it to you. Okay, that's great. Thanks a lot.